In this video, we will be talking about trig substitution. So let's try to find the integral of root 1 minus x squared. So one thing to note is whenever you have the integral of a squared minus x squared, you want to substitute x, which is equal to a times sine theta. So let's do an example here. So in our example here, we have 1, which is actually equal to 1 to the power of 2 minus x squared. So let's substitute x equals to 1, which is our a value, and then sine theta. And let's find the derivative of this in respect to theta, which is simply cosine theta. And this can be rearranged as dx equals cosine theta d theta. And let's move all of this and clear some space. Now let's substitute everything. So we have the integral of root 1 minus x squared here. So it is now sine theta squared. And then dx here is equal to cosine theta d theta. And now we have to work with the root of 1 minus sine theta. Remember the trig identity where sine theta squared plus cosine theta squared is equal to 1. And let's isolate for cosine theta squared. So this is equal to 1 minus sine theta squared, which is what we have here. So we can substitute that. So we have the integral of root cosine theta squared times cosine theta squared. And then the root can just, since we have a root and a cosine theta squared, it would be cosine theta times cosine theta. And this is equal to cosine theta squared. And then now we can simply use the identity where it is the integral of 1 plus cosine 2 theta over 2. And now let's integrate this. So this could be split into two parts. So we have the integral of 1 over 2 plus the integral of cosine 2 theta over 2. So let's find the integral of this. So the first part, so the integral of 1 over 2 is simply theta over 2. Remember we're finding the integral in respect to theta. And for the second part, the antiderivative of this is sine 2 theta over 4. This one's a bit more challenging, and I'll leave that as an exercise for you. Anyways, and the antiderivative of this is theta over 2 plus sine 2 theta over 4 plus c. And now we're not done yet. So remember we substituted everything for theta and sine theta. Now we have to substitute everything back to x. So first let's work with the theta here. So remember our equation here, we have x equals to sine theta. This is actually equivalent to theta, which is equal to arc sine x. So this is actually equal to, or the same as, sine inverse x. Let me rewrite that. So this could be replaced with arc sine x over 2. And then now we work with sine 2 theta. But over here, this is only sine theta. So we would have to use another trig identity. So remember, sine 2 theta is equal to 2 times sine theta times cosine theta. So let's write this. So let's write the over 4. So 2 and then times sine theta. So sine theta is actually equal to x. So it would be 2 times x. And then the cosine theta is actually equal to, so now over here, we have cosine theta squared equals 1 minus sine theta squared. So this is equivalent to cosine theta, which is equal to the root of 1 minus sine theta squared. So this could be replaced with 1 minus sine theta squared. So whoops, let me rewrite this. Sine theta squared. And don't forget the plus c constant. This could be further simplified to arc sine x over 2 plus, and the 2 and 4 cancels out to over 2. So x times root 1 minus sine theta squared over 2 plus c. And here is our final answer for our question. If you found this video helpful, please leave a like and subscribe. Please comment down what other videos you guys would like to see, and thank you very much for watching.